Hello, hello, hello. Hey, students, how y'all doing? Hope you're having a good week. It's just Monday, I know. But we'll get through it, right? We have Halloween this week, right? So get your trick or treat on or, hang out with family and give out candy, whatever you got to do. But it should be fun. So I was blown away again, man. You guys gave me a ton of topics you wanted help on. Some of them I've covered, some of them we could cover for days. So I'm going to provide a lot of resources, but I was just going to try to dive kind of in depth on a few of these because they're really important. Okay, so the first one, let's look at the periodic table because that's really important. Everybody's going to have that in a class at some point, and if you don't understand it, that's going to be tough. So let's look at the periodic table. We'll go to that one first. I found a nice, I think, periodic table to use here to go over this with you. And you should be able to see my screen now. Yeah. Okay, so here's a periodic table. If you notice, hydrogen with the number 1 over here, and we'll talk about what that is in just a second, is way over here. And then you've got Lawrencium 103 way down here on the bottom right. Okay, so what does all this stuff mean? So the number in the top left here, like the 1 on hydrogen, is the atomic number. Okay, this was invented by Dmitry Mendeleev. You'll probably hear his name if you have a textbook or anything. I'm sure it talks about that. I was gonna see if it gave you definitions here. If not, I'll just go through them. Yeah, so I'll go through them here. So the atomic number is basically the number of valence electrons, which is also equal to protons, okay? Because they cancel each other out charge-wise. An electron has a negative charge, a proton has a positive charge. So if you have both, you have a neutral atom, which is not an ion per se. Um, and then you have these other numbers, the atomic mass, okay? So if you subtract the atomic number, which on chlorine here would be 17, from the atomic mass 35, you get the number of neutrons, another particle that has no charge. It's neutral, hence the name neutron. And so 35 minus 17 would be 18. So chlorine would have around 18 neutrons, 17 protons, and 17 electrons, because remember, the electrons and protons are equal. Okay, then we have the name here, the symbol here, and they even put the chemical group block here. It's a halogen. Okay, and let's see, they group them by all kinds of neat things on here. There's another one I found that actually shows you when they boil and freeze and everything, and you can move a little slider to change the temperature. It's kind of cool. It's not that cool, but it was different. But yeah, so in the first row, all of these atoms or elements are in group 1. That means they have one valence electron, which means, remember, all electrons really want to get to 0 or 8 valence electrons because that's how they become stable. And so these are highly reactive. They have one valence electron. They want to get rid of that thing. So they would love to make an ionic bond where they give up an electron and bond with another element. And so they're very reactive. Actually, most of these you have to store under oil because if they touch air, they explode. They're so reactive, okay? Group 2, a little less reactive. They become less reactive as you go to the right. And as a matter of fact, these elements over here in group 18 actually have 8 valence electrons, which means they're not reactive. They're very stable, and you can't hardly make them react. And that's why we use those for certain purposes. Like helium, you can put in balloons. It makes the balloon float. You can inhale it, exhale it, make that funny voice where you talk with a real high voice. It won't hurt you because helium doesn't react with anything. Same with neon, argon, krypton, xenon. They're used in lights and things a lot because they won't hurt anybody if the light gets broken or something like that. They're not harmful like that because they don't react very well. So anyways, as you go to the right, they become generally bigger atoms in terms of particles, but also less reactive, and they have more valence electrons in terms of, well, they can become unreactive if they have 8. Whereas over here, they start with 1 valence electron, 2, 3, 4, 5, 6, yada, yada, yada. The ones with 4 and 3 and 5, they like to do covalent bonds more because they can share electrons to form 8. Whereas if they're 1 or 2 or 6 or 7, they usually do more ionic bonds because they can just give up or gain electrons and become stable at 0 or 8. So in like group 4, titanium, and then also group 14, which has 4 valence electrons, carbon, silicon. These are the elements of life because they can bond with so many different elements, so many different ways. They can bond covalently, give up 4, gain 4, bond with themselves. They can do ionic bonds, all kinds of stuff. So they can make very big, large, complex molecules which are necessary for life, like DNA, which is an amazing compound and huge. They say that DNA in each cell of your body, and we all have billions of cells that make us up. If you unravel the DNA code, it's a code, but it's also a molecule. If you unraveled it, it would reach all the way to the moon and back so many times. I don't remember the exact number, but that's how long and complex that molecule is. It's amazing that our bodies have those in every single cell. So anyways, but you have to have elements that have 4 valence electrons like carbon to be the basis for all that because they can bond so many different ways. They can give up 4, gain 4, give up, you know, a different number to bond with other elements. I mean, they can bond with themselves. They're very important. Carbon is very important, and silicon as well. Scientists have said that if we ever find life in outer space, which I don't know if we will or not, but it'll probably be based on either carbon or silicon because they have 4 valence electrons. Anyways, these have different labels. So you have alkali metals, alkaline earth metals, transition metals. So these are all metals technically. And then over here you have metalloids, which are similar to metals, and then nonmetals and noble gases, which are unreactive basically. So yeah, just certain ones bond with other ones, and you need to become familiar with those over time, but it's not a huge deal. And yeah, so there's how the periodic table works. So let's say you have an atom of fluorine, and you wanted to find something that would bond with that to make a compound. So fluorine is in group 17 here, which means take the 1 off basically. It has 7 valence electrons. What would it bond with? Well, you want to make either 8 or 0, right? So you're not going to give up 7 electrons. Usually you're going to gain 1. So the ones in group 17 will want to bond with elements in group 1. So hydrogen fluoride would be HF, okay? Because the hydrogen will give up 1 electron, fluorine will gain 1, and then it'll have 8 in its outer shell, and they'll both become stable and bond together. So that's kind of how this works. Remember, you want to make them add up to 8 or 0. 8 or 0 generally, okay? So that's a little kind of just overview of the periodic table. Let me know if you have any other questions on that. I guess one more thing I should tell you is that sometimes you get different versions of the atoms of certain elements. Trying to think of a good example. And off the top of my head, I don't know. I think iron might be one. Even oxygen, sometimes you can find it what you call an isotope. Let's use iron for example, okay? So normally iron has 26 protons, 26 electrons, because remember those are equal, and then about 56 total particles. 56 minus 26 would be 30, so probably 30 neutrons. Sometimes they actually lose a neutron or don't have all of their neutrons. And so you could have iron, say 54, and you identify it by the atomic mass because it would be different. That's called an isotope. It just means that it's the same atom, but it can behave a little differently because it lost a neutron, for example. Okay, so that's all an isotope is. Certain isotopes are used for certain things. I'm not going to get into all of that because it could take all day. But by definition, that's all an isotope is an atom of a certain element with a different number of neutrons than usual. So it has a different mass number, atomic mass number. Okay. An ion is an atom of an element that lost or gained an electron, so it now has a charge. So if hydrogen lost its one valence electron, it would now have a positive charge because it would have one proton and no electrons. So the net there, those usually cancel each other out, but the net there would be +1. So it would now be an ion of hydrogen, if that makes sense. It just means they have a charge now. Okay. I think that's most of the basic stuff you need to know on the periodic table. I would get on here, play around with these, and see which ones bond with which ones to get to 8 or 0 generally. And yeah, let me know if you have any questions on that, okay? Let's move on to another topic now. This one's kind of interesting. I had somebody ask about causation versus correlation. I think they have a psychology or sociology class. And in those subjects, what we look at a lot is data. And so if we see like 90% of people that do this happens, you can start looking at patterns of behavior and things like that. But you have to be very careful because sometimes you might think, well, if 90% of these people do this and this happens, that's causing it. And that the factor A might be causing that outcome, but it might not be. For example, I think you'll like this for Halloween, okay? If you look at data of temperature and the rate of murder, they go, when the temperature goes way up, the rate of murder goes way up. And so there used to be a joke in psychology that when ice cream sales go up, the rate of murder goes up. And people were like, oh my God, ice cream is causing people to go murder people. And no, that's the data would show that. It shows correlation. So a correlation, let's define this real quick, is a statistical measure of the relationship between two or more variables. So yeah, it actually talks about it here. I think the ice cream thing, pool drownings. Yeah, okay. The one I always heard was murder. But so when ice cream sales go way up, the murder rate goes way up, and people are like, "Oh my God, ice cream sales are causing people to go murder people." No, it's actually because the temperature goes up at the time ice cream sales go up, and people become more agitated and violent in super hot temperatures in general. So a lot of people would theorize causation, where the ice cream is causing the murder rate to go up, but it's not. It's just a correlation. So you have to be very careful. Just because it looks like something causes something does not make it so. And so you always have to be very careful and aware, especially in social sciences, of causation versus correlation. You will see a lot of correlations, but those do not mean that there is causation there. And so you have to be very careful to do your research and eliminate other factors and other variables, okay? So just something to keep in mind. Let's move on to another topic. Let me know if you have questions. Somebody was asking about the 10th Amendment. So I was going to go over that and then just a really quick, brief overview of all of the constitutional amendments in the United States. So the 10th Amendment says the powers not delegated to the United States by the Constitution, nor prohibited by it to the states, are reserved to the states respectively, or to the people. What does that mean, Mr. Crane? All right, so if there's a power that's not delegated to the federal government, that's the United States, in our Constitution, so the Constitution doesn't say that the federal government has this power, like to handle the border and immigration issues. If you pick something else and it doesn't specifically say the federal government has that power, and that power is not specifically taken away from the states, so this is really confusing, but if the Constitution says that the federal government doesn't have power A and the states do not have power A, then it goes to the states, power A, okay? It's reserved for the states. So what does this mean? Basically, anything that's not specifically assigned as a power to the federal government or assigned away from the states goes to the states. In other words, our founders wanted the states to have anything they didn't think of in their purview first. The states were supposed to be like each little individual countries that are binded together by just a few laws from the national government or the federal government. And the states should really be the government that you're dealing with most of the time. They wanted it to be more local to us, so it was people closer to us, so it's people that have to listen to us more, rather than Washington, D.C., thousands of miles away, making all the laws for wherever you live. Our founders did not want that. And so they reserved any power not specifically listed to the federal government or not specifically taken away from the states in the Constitution automatically lies within the states as a power. Okay, so that's what the 10th Amendment is saying. I hope that makes sense. The wording of this is a little wonky and it's hard to explain, but yeah, basically any power not specifically given or taken from the states or given to the federal government or taken from the states belongs to the state governments first, not the federal government, okay? So this is again a way to limit the power of the national or federal government and give more power to the states, as our founders were big on, so that your government is more local to you, has to listen to you, is closer to you if you want to go yell at them, and instead of somebody thousands of miles away telling you what to do, okay? So that's the 10th Amendment. Very important amendment. Do we follow it today? No, we don't follow most of the Constitution today. We're in a post-constitutional America. It's pretty scary. I don't know how that's going to end well, but we're about to find out, I'm pretty sure. So anyways, just know that most of our Constitution, we don't even respect it or use it anymore. And in my view, that's pretty sad, because it's they did a lot of research on it. It's really a great document, I think, if you care about individual rights and freedoms, which I do. But if you're a Marxist or a socialist, which we have a lot of today, this thing is probably terrible to you. And to me, how that always turns out is terrible. So I'd rather have the freedom and the rights. But that's just me. A lot of people disagree, and our country's split just about 50-50, it looks like, if you look at election polls on a lot of this stuff. So anyways, it is what it is. Let's look at a real quick overview of all the amendments. Excuse me. Okay. I'm not going to go through all of these. The First Amendment, freedom of religion, speech, press, assembly, and petition. I hope you get those and why those are important. Second Amendment is the right to bear arms. Third Amendment is the right that to not, excuse me, have the government quarter soldiers or have soldiers live in your house. Again, these are going back to exact specific complaints against the British or the English government and what they tried to do to the colonists at the time. Um, Bad stuff, man. Bad stuff. Search and seizure, how that can happen or not happen. Grand jury, double jeopardy, self-incrimination, due process, takings, right to speedy trial. So this is a good example. Why would our founding fathers put this in there? Well, because the British would just lock you in jail and let you rot for years and never give you a trial, even though they could have. But that's a way to lock you up if they can't prove you're guilty. Um, it's 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 how kings and queens and corrupt governments deal with their political opponents in a lot of ways in the past, present, and future. So that's why, for instance, that is in there specifically, and why most of these are in here specifically. Okay. Seventh Amendment, jury trial and civil lawsuits. Eighth Amendment, can't do excessive fines, cruel and unusual punishment. Just imagine what the British government was doing to our founders that they put that in there. Okay. The Ninth Amendment, non-enumerated rights retained by the people. In other words, if it's not specifically written in as a power for government, um, then the people have that as a right. Okay. So basically, anything we didn't list as a right, um, or how can I explain this? So the Bill of Rights lists specific rights, and this one basically says there are other rights that we didn't specifically list, but they're still rights retained by the people. In other words, you have more rights than just those listed in the Bill of Rights. It was just making a list of the crucial ones and ones that would be challenged early and often, so to speak. Okay, I hope that makes sense. 10th Amendment, we just went over that. 11th Amendment, how do suits against states work? 12th Amendment, how does excuse me, how does the president, vice president get elected? Then we have our Reconstruction Amendments where we got rid of slavery. 13th Amendment got rid of slavery. 14th Amendment provides rights to former slaves and basically says they are equal under the law. And the 15th Amendment says the right to vote cannot be denied by race, which happened in the South after slavery. So that's why they call those the Reconstruction Amendments, okay, right after the Civil War. 16th Amendment, they started the income tax in the early 1900s. That was actually illegal at first, and the founders had it where the states could tax you, but not your income. They could either do a sales tax or other types of taxes, and the national government just did tariffs mostly um, to earn money to fund the government. Um, our founders were terrified of an income tax because the government, once it has its hand in your paycheck and gets part of your paycheck before it goes into your bank account, there's nothing you can do to stop them if they get out of control. Whereas if it's a sales tax, like the founders set it up, if you wanted to starve the government of funds because they were out of control, you could just stop buying new stuff, make your own clothes, grow your own food, and they would run out of money and you wouldn't have a national government to worry about anymore. So Alexander Hamilton detailed that in one of the Federalist Papers of a way to starve the government into submission by using sales tax. And they were very much against an income tax. But here we are. 17th Amendment, popular election of senators. So this is where Woodrow Wilson got the government to throw out the founders' plan where senators were chosen by state legislatures so that senators would represent the state governments against the national government and protect the states from the national government. That is no longer there. Now they're elected by the people. And so the couple of problems here the founders would say is the states no longer have a way to fight back against the national government with senators anymore on lawmaking. And now you have people electing them instead. And so it kind of defeats the purpose of senators being beholden to the states and not the people, and doing what was more in our best interest long run versus, say, representatives in the House that are very sensitive to the people's whims because they got to be reelected every 2 years. I talk about this a lot more in the government extra credit video I've sent out to you guys probably by now. Um, it's really, I think, genius and at least inspiring to see how much thought the founders put into the design of the length of term and how our representatives, senators, and president are chosen. And their reasoning behind it is amazingly interesting to me, and how much research and discussion they had on that. So it's pretty neat. They really did their homework, but it takes a lot of research to understand it all. But anyways, you should look into that more if you're interested in how somebody might design a government for the first time people get to design a government. And they really did a good job overall. 18th Amendment was prohibition of liquor. Again, during this time of the progressives, where we want to make the government more responsive and move quicker and get more things done. The scary part would be to a guy like Thomas Jefferson is you don't want the government getting more done because it's usually bad stuff where it's taking away your rights. Anyways, and then they decided that it would be good to outlaw liquor or alcohol sales. And there was just so much violence from it within the country. Quite a few years later, they decided to repeal this amendment. 19th Amendment was women's right to vote. 20th Amendment was presidential term and succession, Assembly of Congress. It was more of a clarification of how all that works, and they took care of like tiebreaker issues and things like that, if I remember correctly. 21st Amendment was the repealing of the 18th Amendment, so they made alcohol legal again. 22nd Amendment was in response to FDR being elected for 4 terms. My daughter actually asked about this for her government class the other day. If you look at George Washington's presidency, remember he served 8 years. I think he did either 7 or 8 executive orders the whole time he was president, so about 1 a year. That's where the president basically passes a temporary law or policy that is legally binding for emergency situations, and was only meant for emergency situations. But other presidents later on used that to abuse their power and to get around the Constitution. So, for instance, George Washington passed, it was either 7, 8, or 9 within 8 years, about 1 a year. FDR, while he was president, passed over 4,000 executive orders. 4,000 executive orders. Washington was 7. FDR was 4,000 executive orders. You can see why people were worried about him becoming a tyrant and abusing his power and becoming too powerful from being in there too long. And that was just one example. 23rd Amendment, presidential vote for DC, so they get to have elections for president. 24th Amendment was abolition of any poll taxes. 25th Amendment, presidential disability and succession. So if the president becomes incapacitated or is having mental issues, which has been coming up a lot lately, then you could use that to do something else. 26th Amendment made the legal voting age 18. And 27th Amendment is congressional compensation. So yeah, there's all the amendments we have so far. If you have any questions on those, let me know. We went over the 10th Amendment. We went over the periodic table. Molar mass and molar mass calculations. I'm going to put some resources in. A couple students asked about that. Molar mass is how much 1 mole of a substance weighs, which is based on the atomic mass of the substance. So if that number is bigger for a certain element, they're going to be heavier for that element. And here's one way to calculate that. So you take the carbon atoms times the mass, hydrogen atoms times the mass, oxygen times the mass, add them all up, and that gives you grams per mole. Yeah, it's a way of numerically representing masses of compounds and elements, okay, in a unit they made up called a mole. Okay, so I'm not sure what else to say on that, but I will provide some resources if you need help calculating these, okay? And then finally, I think this is the last one. Excuse me. There were others, but I'm just going to provide resources because some of them aren't going to be in a lot of classes, and a lot of you won't want me talking about them for a long time. Uh, but this was a really cool American Revolution timeline because I have a lot of people asking about different um, topics on that. Gitan asked about Continental Army battles, which I find fascinating. I could talk about this for hours, but I shouldn't do that to you. So I was just going to provide this resource. It's really cool. It goes all the way back to the French and Indian War and basically traces up to the creation, excuse me, of the Constitution and everything. And there's a lot of neat battles in here. I was going to just point out a couple to you. June 20th, 1780, Battle of Ramsauer's Mill. I know a lot of you guys know I play in a rock band. We actually wrote a song about that, which it's nothing to write home about, and I'm not saying you need to go listen to it, but the point was this battle is really interesting because what happens in this doesn't happen very often. The two sides actually run out of ammunition, and it becomes like a boxing match, Royal Rumble to the death. So both sides just start beating each other up until the other side surrenders, and a lot of people die by fist fighting, and it's just crazy. One of the craziest battles I've ever heard of. I don't know that it had a really big impact on the war, but it's just how often do you hear about something like that, like a cage match to the death with hundreds of people? It's just insane. Um, anyways, some of these other battles are really interesting just because of what happened, and you can click on these links and go find out more. And I'll provide this as a resource. The history with George Washington in this war is fascinating because his whole life is fascinating, but in this war, he loses like the first 8, 10, 12 battles. I don't even remember the exact number, but we're just getting beat up. And then finally, he starts winning a couple battles, and then the whole thing starts turning around because everybody comes out and supports them more once they get a couple wins. And he wrote in his journal that he thought we were going to lose, and it was a miracle from God that this whole thing turns around because they were getting beaten, defeated so badly at so many battles, and he gives credit to God for turning the whole war around. So that's where how dark of a place he was in and how depressed he was becoming as they were getting just trounced by the British military at first. And it's fascinating to see how it all turns around. Um, if you want to know more about a specific battle, I could talk about that with you in another video, but this is a really cool resource. You can go read about all these. It's amazing. It was an amazing time period, and it's amazing that it all turned around for the United States, and how that happens. And George Washington and the other founders, they do some amazing things in this war. You should definitely go read more about it. It's worth your time to see how they were being punished and persecuted by the British king and the horrible things he was doing to them, and how we might see those things again someday, and then how they reacted is really interesting. So I mean, I was a psychology major in college originally, and just to see the thought process behind a lot of this is to me fascinating. But then there's all these heroic events that happen too. It's really, really good stuff. And I think for the most part, you should be really proud of your country and how it formed and the ideals it was formed upon. And most of these guys, I'm not going to say they were good men or bad men, but they had good intentions, and most of them, a lot of them were trying to secretly work against things like slavery, and to try to pass laws that would set that up to become defunct at some point and to be done away with. Just a lot of people don't understand that. But yeah, really interesting time period, and I'll provide some more resources on that. Okay, I just want to make sure I haven't missed anything that was crucial. There will be a lot more topics, but yeah, that's the main ones. So I hope you guys have a great week. Use that extra credit wisely. Keep working hard, and let me know if you need any help. You guys take care, okay? Woohoo! Happy Halloween.